Okay, so here's our first review video for the regions. It's going to be all about vectors, scalars, some basic math, and units, of course. So starting out with vectors versus scalars. Okay, so vectors are direction and magnitude, whereas scalars are just magnitude. Okay, but they all have to have units associated with them. Some examples of vectors include displacement, velocity, acceleration, force, momentum, electric field. Okay, things that are scalars are distance, speed, work, power, energy, electric potential, electric current. Okay, those are all things that are only magnitude. You don't have to worry about direction with those. Now, a lot of times on the regions, they'll ask you questions like, which of these could represent a vector. So they might have things like, choice number 1 could be a Coulomb per second. Okay. Choice number 2 could be a Newton meter. Choice number 3 could be a Newton per Coulomb. And choice number 4 might be just a second. I'll say which one of these represents a vector. So a Coulomb per second is current, so that's not a vector. Current doesn't have direction necessarily, at least when we calculate it. A Newton meter, a Newton meter is just work or energy, so that doesn't have direction. A Newton per Coulomb, that's electric field. Electric fields do have a direction, so that would be our vector. And 4 seconds, that's just time. Time does not have a direction either. Okay? So make sure you know the units that are associated with those vectors and scalars as well. Now, in terms of vectors, remember that a vector is simply just, an arrow that represents some sort of magnitude. The length of the arrow represents the magnitude, and the arrowhead is the direction. Okay? So when we add vectors together, we always add them tip to tail. Let's do this. Okay? So if this is our first vector, we want to add another vector to it, then we can simply add it tip to tail. Okay? And our resultant would then be the entire length of the two together. Okay? That's our resultant. So if we want a maximum resultant, so the max would be if the vectors were in line, so a difference of 0 degrees, okay, just like the one I drew below. For a minimum resultant, they would have to be 180 degrees apart. So you'd have one going one direction, and the other one would then be, going the exact opposite way, but we still add it in the same rules. So we take the tip of the second one, add it to the head of the last one, and then our resultant would then be this little bit right here. Okay, that would be our resultant. Don't snap to that. So that gives us the least resultant is when they're going in opposite directions to each other. Now, if they're at an angle to each other, so maybe you have one going this way, and then you have another one going up this way. Okay, our resultant would be this vector right here. Now, that resultant can be found using Pythagorean theorem, which is just simply, a squared plus b squared equals c squared. Okay, where a would be here, b would be here, and then we solve for c. And from that, you can use trig to find the angles as well. Now, sometimes, they only give you something at an angle, and they'll tell you what that angle may be. They'll say that the angle between this vector and the horizontal is 35 degrees. Okay? Whenever they give you something at an angle, and let's just give this a value, let's say they said that this is a force of 40 newtons. Whenever they give us something at an angle, first thing you want to do is break it up into components, because we never ever need this 40 newtons. Okay? We never use that in an equation. We only use its components. So it has a vertical component going this way, and it has the horizontal component going that way. So we use those equations. AX equals A cosine theta, or AY equals A sine theta. Okay? This being AX, and this being AY. Okay? This A in both of these equations is this value right here at the angle. So that would be, A would be 40 newtons. And of course theta would be our 35 degrees. Now, in terms of the calculations and the math that you have to do for everything, make sure you do the three-step method. Okay? So step one, equation. So for example, F equals ma. Nice simple equation. Step two, substitute with units. So maybe they told us that the mass was 5 kilograms and the acceleration was 3 meters per second squared. Okay? If you forget the units in your substitution, you lose half credit automatically. If you forget to put the equation down like step one, you lose half credit automatically. Okay? And step three is your answer with units as well. Okay, so F equals 15 newtons. Now, let's say that you're going along in the test and you forget the units of force. So you know that there's some sort of shortcut, that the force is some sort of label, but you don't remember what it is. Simply use the ones that you've already plugged in, these kilograms and these meters per second squared. So you could simply write force equals 15 kilograms meters per second squared, and that's 100% okay. That's perfectly correct if you can't remember what that original one is. But make sure you do it correctly. All right. Other things that we should just briefly talk about is sometimes they'll give you something, especially if we're talking about light. They'll say the wavelength of the light is 700 nanometers. Now, you can't use nanometers in your answer. So instead, what you can do, let me just bring something in here. Okay. On the cover of your reference tables, you have prefixes. So automatically, when you see something with a prefix like that, nanometers, automatically right away change it into regular meters. And all you have to do is, if you look here and see, here's nano times 10 to the negative ninth. Don't do anything with these first numbers. Just do 700 times 10 to the negative ninth meters. Okay? Simply replace that nano with 10 to the negative ninth. Okay? Sure, if you wanted to, make it a little bit easier on yourself, you could do 7.00 times 10 to the negative seventh. Means the exact same thing, but get rid of those prefixes. All right? The only time you're not going to get rid of a prefix is for kilograms. Kilograms is a base unit in physics. Everything else, you're going to get rid of that prefix. It makes your lives a lot easier. It makes the units work out. Otherwise, you're going to have lots of different crazy units. So if they give you something in centimeters, change it to meters. Give it to you in millimeters, change it to meters. Okay? If they give you something in micrograms, change it to kilograms. If you have any questions on any of this basic intro stuff, feel free to stop by and ask me. The next one will be on mechanics and graphs, dealing with mechanics.